Each person's spacetime is unique. No one can exist in everyone else's. I'm in a private area, so no one can exactly the same way I do, except your spacetime is nearly perfect. So your experiences are similar to mine. Human identifiability. Meaning of black holes warping spacetime. Nearby spacetime is very large. Unlike the spacetime around us, the last video demonstrated what this entails. Space exhibited behavior substantially different from what we anticipated this, so let's investigate it now. Warpage is a term for time. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. Even though spatial distortions cause practically difficult to orbit close to a black hole, we are still extremely near it. If we have powerful engines and bones, if we just direct our engines in that, we are able to withstand the sultry oneness approaches the black hole's curved surface. Obviously, this means that our engines must, the more recent we are, the more production there is received, indicating that the residents will experience an ever-increasing. They are pushed downward and into their seats. We're in a bad situation here, because I'm going to act like our ship has some kind of anti-gravity apparatus. What occurs as we near orienting the challenge is inside ourselves. As you go down, the black hole stretches and more light coming down into it from the horizon. This results in the never-ending darkness. To stoop down to us, the photon sphere, as we go through it, the last opportunity for light to come disappears immediately from the horizon. In terms of geometry, we are still outside of, however, to our eyes, the black hole appears to be as if we've just stepped inside. The more light bends as we move forward. From both us and the view from our window, space above contracts. This raises a question. How do we are aware when we get at the occasion? Horizon. Contrary to the photon sphere and the ISCO, there is no clear limit we can pointing, saying, oh, there it is, everything is pitch black down here. Dark colors. We have two options for retaliation. This first instance is merely passively observing our constantly dwindling window above us. It decreases until we are directly involved over the horizon of an event, or we may calculate the separation between the photon sphere, the ISCO, and once we've traveled that, multiply that by 3. Beyond the photon sphere, we've measured across the horizon of an event. Our spacecraft has sophisticated computers, so calculates, and using those distances then have a hologram of the area where we need to look at the event horizon. We arrive at our destination finally. The Schwarzchild is 1.01 radii away from right above the event horizon, a singularity. Our engines are roaring with incredible thrust. Our anti-gravity device and force working extra hours to keep us cozy now that we have the ability to experiment. Strange new world we live in. Prior to entering the black hole, we left a probe at the ISCO in orbit overhead. Whenever the probe flew over it, at 10 a radio signal was transmitted. Megahertz time is a frequency of light waves, depending on if our time is different. Here, close to the event horizon, we ought to use a frequency other than 10 to observe megahertz. This is the time dilation equation, where x is the Schwarzchild's distance. Distances between the singularity and the reference point is of a distant person. By way of the black hole our orbiting probe is close to, we must compute the size of the black hole. When both of these will happen at 1.01 Schwarzchild radii, we discover that our time is passing at the rate of 12 minutes. Each time our probe is used, 8.3 seconds pass for it in this. When we gauge the radio wave that was released, we note that the frequency has increased to 83 megahertz. Time is really passing more slowly now. In comparison with those further distant, now ask the most crucial question possible. Then why does the universe exist? For whatever reason has determined how physics should function. Wherever you are, in the same way are inside it. This is the idea of generalization. Relativity, regardless of the reference light from frames, will always move at the velocity or speed of light. Since is an indication of both space and time, then the only means of maintaining light at its speed, each reference frame of light, is to change the parameters of space and time. Let's examine the space and time surrounding our dark sphere. This is a representation of an embedding. A two-dimensional rendering of space with three dimensions the same way that we do in three dimensions cannot see those in the fourth dimension. Residents here are unable to see the third. Therefore, despite the fact that in actuality everything will, those in this world who are traveling along curves unable to perceive them outside of gravity here, far from the items passing through the black hole exactly like we envision them to in space two-dimensionally. Nevertheless, let's see what transpires when a photon moves closer to our black hole. Given that photons are light, they must move at a constant speed, yet as we observe our photon from a person's perspective, the photon appears throughout the universe. To begin reducing speed, there is a problem here. Despite the fact that we cannot see light in this, conceptually speaking, this is the area surrounding the black. More and more bends into the whole, a greater dimension, and is hence a photon's travel, which we can only see taking place in the bottom dimension by way of the invisible higher dimension. As a result, time slows down, and using gravity wells to provide lighting. Why must I travel this much distance? The apparent speed of light is, I'm not sure if there is a speed of light. Actually, a cause other than physics unable to work. It's crucial to keep in mind that for every occurrence along the path of our light, it seems to be traveling at the rate of it was light for anyone at that time. In case we chose to begin right here and disperse, we'd observe that the longer light travels, the faster it is derived from the black hole. This illustration also displays gravitational acceleration. From a person's perspective, they will be plunging into the black hole. Just proceed straight ahead at same speed, yet due to time begins to move more slowly, they will arrive earlier than anticipated. The philosophical query now is yours: is speedily reaching a destination than anticipated, different from what arrived, but truly somewhere at a faster speed? There are two similar descriptions. Thing gravity is visible at the event horizon. Indeterminate, which means the slope or the entire tangent of spacetime is seen. Vertically oriented means that gravity or flowing as quickly as light, and therefore the only movement of the light is in the higher dimension, hence it is immobile wherever the lower dimension is. Thus time elapses. I must emphasize that everything is relative. Appears to be an ambiguous key phrase. This is how the curve appears mathematically. Without our observer, it would go on forever. This far-off universe is expanding at the speed of light in this context, indicating that entirely shrunk along the manner of motion, and how it appears 100% vertical or undefinable relativity is strange. The final issue we'll discuss today. So, what does it imply to converse mean? With the location or the event horizon where it seems like time has stopped, really not ignore it and return to it. What if a very long pole was inserted from out past the event horizon in our spacecraft, and after that, undoubtedly, pulled it back? It might be feasible. First off, that is a ridiculous idea. Materials could last a long time. That is both close to and resisting integrity. Our planet's gravitational acceleration is dark sphere, although it doesn't harm to consider. The first point to consider is that, like to imagine things as being one whole, the two ends of our rods are something moving as a single unit. Because I'm advanced, the other with this portion of the rod end also travels concurrently. However, the reality is that you place an electron pressure front traveling electrons that are pushed back nearly light speed through our rod as we make our incredibly crazy long descent rod in the direction of the event horizon. The final closest moves more slowly than we are clinging to the end in mind. Consequently, one of two things will occur, and both seem to be true. According to the first theory, the time is perceived by a pole at the event horizon farther away to travel ridiculously quickly. Therefore, as you move the rod in its direction, all of those pressure waves receives rapidly from electrons, and it explodes or disintegrates. But you would be unable to see this, since the event horizon's light would be distorted too much to see. In contrast to the second theory, time is ticking away as we hang on to it. The event horizon is moving absurdly fast. Slow. This generates a powerful pulling force, which, like would cause the rod to snap. Snapping of the rope due to excessive weight. Honestly, don't know and won't speculate which is more probable. Despite what some may believe, if you fall into, you will either blow up or not at the event horizon. Shattered. This is only the result of the fact that staying still close to both the event horizon and beyond it, two quite different emotional states. Both of those states dislike being together. Once you let go, you're connected to one another. It becomes an inertial force of the rod. Reference frame, then all of a sudden is good. This is so even while time is limited. For the portion of the rod closer to the moreover, the issue has an event horizon, accelerated and moving more quickly than the issue in the rod farther away from event horizon, and so there is a balance. Our rod sinks in seemingly at random. Elsewhere in the cosmos thus finishes our detailed examination of the alterations in spacetime near a black hole. There are plenty further topics to cover. The reality of these improbable phenomena, that they may spin or have charges, temperature, and Hawking radiation. Perhaps we should revisit these subjects another day, but the following query is how and why black holes arise.